is keen on collaborating with food majors, agri and food startups for Strategic Food Park and backward linkages with FPOs. The BVG Food Park infrastructure hosts cold storage, ripening chambers, warehouses, and pulp processing lines, aseptic, frozen, and canned for fruits like mango, strawberry, guava, lychee, etc. And for more information, they can visit the website. Sir has also a thorough understanding of farming and tech and is well networked with the startup ecosystem. Sir is instrumental in the startup ecosystem. While at Pegasus facilitated investments in growth stage startups to ensure sustainability, like StanPlus, Taddy Tech, and many more. Further, he advocates for profitability at farms, running the Agro Book and Farmers Balance Sheet. He is a facilitator for Launchfield, Open Design Center for Agri and Rural Innovations, supporting various agtech technology developments, including subsurface efficient irrigation system to drone interventions in farming. Strategic sourcing and business analysis manager with proven skills in leading and managing teams to operational excellence in the area of spend analysis, market intelligence, inventory or materials management, aftermarket, and master's data management of a $3 billion organization. Sounds understanding and experience in ERP implementations in North America, the United Kingdoms, and Netherlands. Now, I would like to request Sir to take over on this very important topic of farm mechanization, sensing, and IoT.
Thank you, Bhupesh. Appreciate all the great work by Agmatrix in bringing the academia, students, agricultural startups up there on this particular forum, where exchange of thoughts, ideas are taking place. I hope I'm audible and guys are able to listen, right?
Yes, sir, loud and clear.
Okay, great. So I was trying to appreciate all the effort that is happening. I could see it's 8 o'clock and still people are there on this particular call. I mean, more than 75 up there. So farm mechanization and IoT is the buzzword in today's time, and how to it is impacting overall life of a farmer, overall farming practices. We will actually, there are a few lessons and observations that I have my own, and at the same time, there are quite a few organizations who come for the funding to express their technologies. I'll try to take through a ride of it. But exactly, what all this is solving, right? Why we all, interacting, studying, probably. So bottom line thought is that at the farmer's end, he should be profitable, right? So when I say that I'm advocate of the profitability, so let's consider, any industry, if they actually evaluate their balance sheet or the profit and loss statement every month, if they figure out they're not profitable in a month one, month two, what they will do, they will change the line of business, or if they are not making money, they will try and try to do something else. But farmers, what is the solution for that? And in fact, when we say farm mechanization, I would like to touch base on the part of the data capturing first, and then I will move to the farm mechanization, and then where I'll do to the IoT. So when I say about the data is the a basic granular ingredient for everybody's understanding. So data can be of a different type. So when I say a profitability aspect, data is that what all we purchase and put it in our farm, including our efforts, including the agricultural inputs like fertilizers, pesticide, a service that we actually utilize by hiring a tractor, all that goes into the cost of cultivation. So when we try to sell our crop yield to the market and do the economics, that is basically We are trying to do the data crunching in terms of figuring out our profit and loss statement, or whether we are profitable or not. And to my observation, majority of farmers, if the rent of the land is considered and the money paid on to the self when we are working in our farm, we are not so profitable. But still we are doing, because there are no options available, and it's continuing. There was a survey in 2015 around that, uh, whether farmers are quitting the farming or trying to identify the different jobs. There was a observation made around 2,700 farmers across India in a day are quitting farming. And why is that? Because of the profitability aspect. When I say that profitability aspect, we are spending money on the labor, we are spending money on to the various equipment, seeds and fertilizers. And with inflation, everything is on a rise. Okay. So when it is on a rise, the labor uh, uh, is also on to the rise. So that's make a perfect case of, utilizing certain equipments or introducing farm mechanization. And also, previously we used to do the cultivation with the help of the bullocks, and for 1 or 2 acres of plowing, it used to take a complete day. While in today's time, a tractor does 20 acres. Now imagine 1 acre, the deep toiling, while um, the bullocks, it's replaced by one tractor. That means around say 20 persons man effort are now taken up by one person's man effort when he is onto the tractor, and 40 number of bulls are replaced by a tractor, right? This observation. So so for a farmer, this is one example of the efficiency that one have received. So in today's time, if we consider employing 20 people for 20 acres for that particular day, it's a huge cost. So it is very logical that the farm mechanization brings down the cost of operation. That is number one. And number two, it also brings down the time of operation. In today's time, if we consider or figure out the different steps in the farming, so I have taken the example of plowing itself only, but taking out the grass, you doing the fertigation, doing the spraying. In today's time, we have to do the analysis in terms of, say, soil testing, or figuring out where are the diseases. So if we do all this work manually, there is a lot of manual labor will be required. So it is very much evident, or very much necessary, that we employ the mechanization aspects into this. Bhupesh, if you enable me the sharing of the screen, I believe it is enabled. I'll share one slide deck and I'll take you through. So So bottom line is that we all have to be, profitable by employing the various techniques, and farm mechanization is one of it. Now, if you see this particular, infographics that is here, this infographics talks about of the, say, world map. This is the Canada, this is the US. These are the major agrarian, nations. So up here you see the Russia, up here you see the China. Here is our India, and sorry, here is the India, and then here is the Africa. So what is happening? All these big nations, with their population, they are trying to secure their food security. I mean to say, for their population, when we are further, into future, there is concern about whether we'll be able to grow enough or not. So we are securing the farmland for our country's need. and majority of them are actually sourcing their lands in the African continent. And in some conversations, you must have heard about that the large land banks are there in the Australia and African region. So these large land banks actually are able to deploy the cutting edge farm mechanization to their farms. So that actually brings down the cost of cultivation. Now, when this cost of cultivation brings down, we majorly, who are the small farmers in India, are a semi farm mechanization we do use. So these large farms are also are having the cost advantage where we fail. So in tomorrow's time, we have to figure out how this farm mechanization at the large farm is going to impact us also. You probably had an example of 2 to 3 years back, or probably 4 years back. The arhar dal used to be like 200 rupees a kg in India, and then we imported it from the Mozambique country, which is in Africa. And why we were able to actually get it at a lower cost? Because there it is cultivated at the in the industrial farms or the large farms. So their farm mechanization is making the impact. So similarly, in Indian context also, we have to figure out how this is going to impact us. And it's a challenge for all of us as of now, though it is not visible because we are protected in one or the other way, that we the government regulates the import and export of a certain commodity, so certain prices are actually protected. But in future, there could be the change of order, and in that scenario, it's a hit. So we all have to actually figure out what sort of data is getting generated and whether it is going to impact our farming or not. Now, why, another example, why basically the, farm mechanization is happening. So one example or one scenario I tried to put through there is says 2,700 farmers per day are quitting the farming or the farm labor. So that does mean day by day we will have the less number of farm labor or people to work into the farm. It's mine example itself. So I used to do the farming, and then I had a better education. I had a better opportunity. So I worked as an investor. I worked as the IT professional. I'm working as the professional who lead the agri and food ecosystem up there. So certainly I want to do a larger value work, and the different systems. So systems which enables me to do that value work. I'll certainly try to quit the bottom of the pyramid, task. So similarly, now new generation who is equipped more with the further knowledge will try to also move towards the urban for the better opportunities. So necessarily, what's supposed to happen, that the less and less number of people will be into the rural areas to do the cumbersome work into the farming. And at the same time, why someone should do the cumbersome work and not to go for the better opportunity, one should go for that. And that is the natural phenomena that is happening, and that is making a situation very imperative to go for the farm mechanization. Now, what are the number of farm mechanization, or what types of the mechanization that the farming systems will have? So whatever task that is repetitive, tedious, boring, that is the first one to get replaced. So uh, if you see this picture, say if it is the context, in the context of the nursery, that the plant movement from the one point to another point is happening, or you have seen the examples of the rice transplantation. We used to do it manually, but now there are machines which can do the job efficiently. So wherever there is a repetitive task, and that can be replicated with the machines, it will be taken care of. Now, when we say that repetitive task, what are those? So plantation is one. Spraying, I mean, in certain commodities, we probably do 20-30 spraying where it is more disease prone. In some cases, we manage it with 3 to 4 in that particular crop life cycle. irrigation. Every time we have to go and switch it on, switch it off. But nowadays we have the auto or the interventions which are capable of managing that irrigation aspect from the our phone itself, or in tomorrow's time. In fact, there are proven cases where the uh, the detection of the moisture itself trigger a signal, and that signal ensures the no more wastage of the water to take place. In the harvesting also, it's a kind of repetitive task, and uh, if it is the um, where one has to ensure, because I'll just try to give a scenario. So uh, when you are employing a labor and you ask him to only pick the ripened cherries, and if your compensation is based on to the weightage, the person will try to pick the non-ripened cherries also, or the non-ripened fruits also. But when you are employing a robot and you have given an algorithm to pick only the ripened berries, which is able to get detected with the help of the computer vision technologies, where the spectral imaging that employs and figures it out. Okay, this is the ripened cherry or the fruit, that only gets picked up. So there is a lesser chance of error that can happen, and then a farmer who's having that particular farm can employ and can get more returns on it, because he's not picking up the non-ripened fruit, and which ultimately is going to fetch a lesser price in the farm. So you can bank on the accuracy of the computer vision algorithms up there. So these are the differentiations also, where manual labor can actually make the mistakes, while the mechanization, if it is fed properly, algorithm is working properly, it can give you the right results. Also into the quality uh, testing, or the quality separation or categorization of the fruit sizes, or the ripening of it, the the algorithms can work up there. These are the examples up here. I have tried to put through, which I have given the examples. Now you all have seen that the drones has been making a lot of waves. It's going to replace the spraying. It has replaced in number of you know regions as such. Necessarily, when we do this spraying, we do spray the crop rotation solutions. In some cases, the liquid fertilizers we spray. But we all know that those are a sort of poison, and for a human to get exposed to that particular spraying. We have seen the examples that in a day, probably in 2017, 23 people died in the Yavatmal district of Maharashtra. Several hundred actually were admitted to the hospital because of that fumigation that actually they inhaled, or it was a wrong spraying, or wrong concentration was formulation come to them for the applications. So drone is solving that particular matter. So it's moreover ensuring that no labor lives at risk. But at the same time, in it is not blindly that every time the farm mechanization does work properly. If we see this particular drone image that is getting displayed, um, uh, to some extent there is a groove that has actually got created. So at a point of time, there may be a damage to the crops, so it has to be a balanced pressure one should apply, or one should ensure that while running that particular drone should happen. And at the same time, if the fine balance between the droplets and the rotor movement is not done, it may cause the drift. And if a temperature is high, the small droplets may get evaporated, and a farmer may lose 40-60% of uh, the pesticide that he's trying to spray. So it may be inefficient also. So at a time, when we say the mechanization is to be done, there has to be the right approach to handle it. So if wrong programming is done to a particular machine which is picking up the fruits, it will probably wipe it off because it do not have the understanding of the human intelligence, that sort of. So there is lot of testing, and data has to be fed to the machines, which is able to solve the problem, or the right algorithms gets formed. The mechanization or the data, can be utilized to the crop monitoring at different stages. We can understand the crop life cycle, to a greater extent. Say for a human intervention, it is very difficult to do a continuous observation 24 bar 7, across the crop life cycle, while a camera sensor onto a particular crop can does that particular wonder, and we can utilize this image taken and figure out what was happening at what particular time, if there was a reduction in the moisture or temperature, what has happened. And even at the larger domain, when the moisture maps can be created, we can figure out, correlate it with the disease outbreak of a certain type of pest attacks as such. So now what is happening with this data acquisition that is taking place? People are building the crop models, and those crop models, in the end, will help the farmers and companies to ensure the proper SOP is developed for the cultivation or taking care of that particular crop and ensuring higher yield. The spectral and hyperspectral imaging are the tools to acquire that particular data, wherein when it is put up into the models, it can help us to get the understanding. Similarly, onto the phenotypic and genotypic data acquisition is also taking place, and that is the basic building block for understanding or giving the data feed to the machines, which on the basis of it can take the right call for which it is programmed. I'll just take an example of here when phenotypic and genotypic data is acquired for a particular crop. Let's take the example of the saffron. So saffron is very pricey commodity, wherein if it is transacted from, say, the origin place, and it is going to the destination, there can be a possibility of replacing it with the inferior quality, while hijacking or taking out the right quality up there. So the level, with the imaging itself, we can figure it out whether it is the right which was shipped at the origin or not. And if the appearance is similar, so phenotypic quantification doesn't help in identifying the differences, then even we can go up to the genotypic level. So that sort of technologies also have got developed, which in turn will help the seed management and identification of the various right genuine varieties as such when it is transported from one location to another location. If you see the precision farming, again, the lot of sensors are getting developed. You must have heard about the humidity, temperature, moisture sensors. I talked earlier about the moisture sensor, if giving feedback to the mechanization of the irrigation as such. Similarly, there are quite a few sensor like heartbeat sensor. You probably, some of you maybe having the pulse sensor in your digital watch. So those applications are also applied to um, the our dairy animals, and from those we can understand more on to the body dynamics, what is happening at what particular point of time in the body of animal. And based on that one, we can take the different calls, whether the calls to the insemination up there, or if someone's health is not right, then we can take a call to call the veterinary doctor. So that also automation is possible. It's just like, I mean, the higher temperature, and then it gives a buzz to the veterinary doctor and get a call. So that sort of cow bells or the buffalo bells has been developed, which comes into the segment of the IoT. This also ensures when large number of the cows analyzed, So which particular breed performs better, that sort of data can be you know um, picked up. Larger analysis can be done, and as I mentioned, like the SOPs for uh, the the crops can be figured out. The SOPs for taking care of the animals also can be figured out. When I say it is applicable to dairy, it is also applicable to poultry or the fishery. So everywhere, the application is possible. Only that expert in that particular domain and right sensors has to be used for it. Um, Based on that, when we are able to figure out certain trends, we can figure out that okay, a particular machine or animal needs a sort of taking care at a particular point of time. So one can be very predictive about it and can plan around it. What particular point of time we can do, the action. The graph, underlying graph that is there, it is taken from see another application which is moreover it is classifying the what crop is grown in what particular field up here. So this is also helping the companies, the state or the countries to figure out how much crop of a particular variety is being grown. Say, for example, if it is the maize, if it is the cotton, or it's a sugarcane. So it can also give an um, input to the policymakers that okay, this particular area, this crop is happening up there. So this is all a sort of a part of Internet of Things. IoT is referred as, wherein this data can help in making the decisions to the granular point is the farmer, then the society or the state and the countries also. So we can better manage the markets also, because at a point of time we are growing without any visibility to demand, and when we get into market, everybody is bringing the same commodity that actually drops the prices, and which is a major factor when we do not receive the profitability at the farm. While this sort of data analysis will help us to ensure that when we are taking it to market, it is to be at the right particular point of time. The supply chain management, basically, I talked about that if it is transitioned from one particular point to another particular point of time, you can enable the commodity with the sensors or that particular box. Ensure that if it is the perishable, then right temperature has to be maintained or not. So when you are actually transporting a container from say Nhava Sheva of Mumbai uh, to the um, to the Gulf, or it is to be in the Europe. In general, what happens? The temperature has to be properly managed. So all that you can understand from the IoTs, you can trigger the signal to the refrigeration system, and the refrigeration system gets triggered on. So the energy efficiency also can be achieved. So multiple applications of can be uh, taken place. As this is evolving segment, all of you must be trying to relate where the farm mechanization will take out the jobs from the farm laborers. Yes, certainly it will take out, but then farm labor is moreover moving towards the upper value chain, so they are getting the higher sort of jobs. So all those who are learning into the agriculture or who's into the labor also will have the multiple different job opportunities that actually will come up in this particular segment with the IoTs and the farm mechanization segment. So you will have to keep a very much say you have to remain updated with what is happening up there, what kind of new mechanisms are coming. I'll just take an example of up here. So this is an equipment I'm trying to showcase up here. So this equipment helps with the IoT is built in it. uh, certain sensors are there. So it helps the moment you take out the milk from the say cow or the buffalo, it can tell you the immediately whether the cow is infested with the mastitis or not. If it is infested with the mastitis, then you can probably take care of it and ensure that further it doesn't actually grow. So it is an IoT device. So uh, and similarly, there is automation happening onto the tilling devices also. So what I'm trying to say is that there will be a lot of opportunities to service. So there was no job to detect the mastitis in the cows. So now this particular device will enable someone as the surveyor who can actually go to the dairies and figure out whether the cows are infested with the mastitis or not. And similarly, for the disease detection or the new sort of tractors will come. Those are the electric tractors, autonomous tractors. So one will have to remove the chip and put up the chip. So that sort of service engineers jobs also will have to do. But then this is the evolution. So what is happening at the juncture of time, that we are building the systems or the industry is building the system. There are quite a few startups who are doing it. So crop life cycle is getting managed. So they need to have the understanding on those parameters. So who can actually do that? So it's the agronomist only who can actually tell this is the paste, and it appears at this particular point of time in the year or the life cycle of a particular crop. So some of you can also be the those observation folks or the programmers also. So it will be additional skill that one should acquire, where uh, you can you can help the new age jobs of IoT system engineer or the developer, or you can be the data analyst, being the agronomist also at the point of time. Um, a lot of these new solutions also need to be taken to the market. So someone who is actually the agricultural companies or seed representative or the pesticide selling guy will have to upskill, or he will not be able to sell these new solutions to the market. So in that scenario, this is an opportunity for the coming new graduates into the market. There will be a lot of service and support uh, jobs up there. I believe a lot of training modules are getting built into the virtual reality segment. Uh, so, so while doing all this, it's open up the opportunities for the new jobs. At the same time, some of you can actually, if you figure out a problem and that problem can be solved with IoT. I have seen people who have built with the help of the IoTs, the machines which can detect the soil uh, uh, classification in terms of the nutrition level, macro and micro up there. So they have built the businesses with the IoT in the farming segment. So the aspect can be you building some solution for the problem, and so entrepreneurship is also an option other than the careers that you can take. So all these new career opportunities will be with the certain startups, or with the industry majors also, when they run their side programs or the research and development programs onto it. So you can keep a watch on it, and certainly these jobs will be high paying jobs than the current jobs of the normal agronomist, or as of now what those are available into the industry, because these jobs certainly needs the analytical skills, and it will bring the scale of economies to any solution that is getting applicated. So the value that is getting created, it's certainly of the higher nature, so people get compensated onto the better level as such. Yeah. So that's all from me. I believe if you have any questions, we'll be able to answer those.
Right, so thank you so much, sir, for this informative session. We have a few questions that we request you to answer, please.
Yeah.
So the first question is from Rupali Shinde. The question is, which practical should be covered in the syllabus of computer applications in food industry, which fills the gap between industry and academia?
Okay. See, if it is the food specific, certainly there are spectral imaging that is happening. I can, provide certain companies who are doing the solutions of, say, with the image, they can figure out the whether there is a microbial development happening on that particular food that is prepared, or the count of microbes based on that, because when you are doing the packaging, you have to ensure that the microbial count has to be under a particular threshold, and if it is above, then probably a batch has to get rejected. So you have to have a sensor or a mechanism which could be of the built out of the multiple sensors, and a mechanism to ensure that it is making a sense of that number of counts. So what I'm trying to say, when you are observing under a microscope, you are able to count it and note it down. But when you are actually using a system should be trained first, and it should be able to understand this many number of microbes are there, and should be put through. So such sort of, I mean, this is one example I have given. We should have in our course curricula also, where we will be able to analyze. I can give this particular um, example to the poultry industry. Say, for example, if birds are not doing good in health, okay, so if you understand their eye movement, if you are able to capture that image, and if the eye movement, I mean the lead onto the eye, if it is slowing down, you can figure out that there is something wrong with the particular bird, right? If you have closely observed. Uh, so so a lot of possibilities, and this possibilities has to be, I'm not sure, I mean, how the academics at the juncture of time, or academia is prone on bringing this literature, because this will need a lot of uh, 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 interaction in the industry, and taking it to and putting it up into the books. I believe it is a long process, but I believe the young generation up here who is listening should not wait for that. You should figure out your own ways to try to do the things. How IoT services can be scalable India in scalable in India? Yes, see, certainly. If you see, the example is that of the auto. So earlier, I used to go to my farm, and used to switch on and off, but now there is auto over the phone. I'm able to manage my uh, irrigation system. So it is the need, or the right need, we have to identify. So for me, it was pretty much risky to go into the night, and then it was the issue on my health also. If I'm getting up in the night and going, so my rest is not completed for my body. So what is happening? The need is identified, and that need is actually served with the solution. Any right solution which gives me a quick, returns on the value. So here I'm getting it. So necessarily there is a adoption. So any adoption is coming from the instant value creation. So any IoT service that you are building, giving the instant value creation, it will help. It will automatically scale. But in some cases, there has to be a customer education, and it takes time. So it's a combination. For every solution, there has to be approach. So when you say that IoT service, we'll have to figure it out what it is, and then based on that, actually, um, a solution can be deployed. Yeah. I hope, I mean, Bhushan, that answered your question.
Right. Sir. If anyone else has any questions, they can directly put them in the chat box, or either they can raise their hands and we'll allow them to talk. I guess so. That's all the questions for now. If there are any, we'll definitely get back to the participants through the email.
Good. Thank you so much, Bhupesh, iMatrix Careers team for inviting me for this particular session. Appreciate all your, efforts again to connect to the right folks. So if you get any questions or someone need any help on to understanding the IoT, farm mechanization, or the uh, what I meant to say, the raising the agricultural enterprises or the startups, would be happy to help. I see there is automation in cotton harvesting is very difficult, area. A lot of companies are trying for that particular, because cotton picking is certainly a very difficult um, uh, task to replicate, because when we pick the ball of cotton, right, it needs a specific action to be done. But then in today's time, there are few um, mature technologies. If rightly moduled it, Punjab Krishi Vidyapit has uh, probably trying this particular solution from probably 5 6 years up there. There is someone who is in Karnataka also has tried this particular. If you need any help on that, how to do that, I can certainly help you. The right approach it can be for the automation in cotton harvesting. We can achieve. Technologies are mature that can be achieved. Yeah.
Right, sir. With that, sir, we sincerely thank you for being with us and sparing your time and giving all our participants a very insightful session. Thank you so much, sir, for being with us.
Yeah. Thanks again. Yeah.
Thank you, sir. Ending today's session is very tough as day after tomorrow we are going to wrap up with the event. I would also like to thank all our guests who joined us today. We are aimed not only to educate our participants, but also to develop relevant skills which could help them in the course of their life. We want people to imbibe empathy, decision making ability, and a wide range of professional understanding so that they could respect each and every work around them. It is important because we all need to develop a society in which our future could flourish. Actually, every education is improper without the value system. Though it takes a lot of time to develop the value system, we can certainly try to revoke them through this event. The diaspora and the range of professions engages with these topics are nowhere to be found, which makes this event a storehouse of value system. I thank all our participants for being with us today. Now, for the last day, we'll be meeting a few more important topics from the seasoned academic and industry experts on agri export, agtech industry landscape, and career opportunities by Mr. Siddharth Bhattacharya from IFCO. Startup and incubation support by government from Dr. Ramesh Mittal, Director, NIAM, Jaipur, followed by the valedictory address from IAS Officer Joint MD, CIID CO, Government of Maharashtra, Mr. Rajesh Patil, to end the program gracefully. So, dear participants, we will meet on the 15th day of training workshop on Sunday, as tomorrow, Saturday, will be off. So, we will resume our session of 15th day of the ATAL program on Sunday, that is 5th of March. Till then, have a great time. See you all at 10:30 a.m. sharp on Sunday on the first session of Agri Exports. Thank you so much again for joining today.